everyone. Now I'm gonna show you how to solve the question for the written word number 1. So as we all know, the question's words is the first question is to find the time is needed for the total work. In here, as the picture they show us, we got a big square triangle, and I named this each side, the size A, size B, and C. The first thing we need to solve for B. So because it's a square triangle, so it's gonna use Pythagoras theorem to solve for B. So it's gonna be here. I want to 8 square plus B square equal to C square, and we just put in the number is 16 square plus B square equal to C is 40 square. So for B is square root of 40 square minus 16 square, and we got 8 square root of 21 meter. So we got the B, and now the thing we need to find, I'm gonna name this one is H, and we want to solve for H to find the time need to walk from here to here. So we're gonna find Z. I name this size Z, and because this small triangle is also the square triangle, so we also use the Pythagorean theorem for solve for Z. For H. And because Z is like in the picture we all see is Z is gonna be equal to B minus X, and B we just got over here is 8 square root of 21. So I'm gonna write down Z is gonna be 8 square root of 21 minus X meter. And so for H, in a small square triangle H, E square equal to Z square plus 8 square, and it's gonna be 8 square root of 21 minus X square plus 16 square. And so after simplify, H gonna be equal to the big square root of 1600 minus 16 square root of 21 X plus X square meter. Okay, so back to our original question is to find the times total need. So we're gonna need to find the time when Clyde walked on the boardwalk, and the time he started working on sand to his umbrella. So I gotta call the time he walked on the boardwalk from here to here is T1, and we got the formula. The time is equals to the distance divided to the speed. So our distance is X, and the speed is we got it here is 1.1. So we need to find T1. We got X1 over V1 is X over 1.1 second. So for T2 is the time when Clyde started working on sand to his umbrella. So the distance here is H, and the speed in here is 0.7 meter per second. So we're gonna have T number 2 is equal to S2 over V2, and X here is H, and H is over here is just big square root of 1/16 minus 16 over square root of 21 X plus X square over 1. Okay, second. So all we need to do here is to combine this thing to find the time total, and the total time I call it the big T, and I also write down here is the big T is going to be equal to T1 plus T2, and we just put it in is X over 1.1 plus this whole thing is so. This is our function in terms of on X that model the time need for the total work. Okay, so move on to the next question. is how far should he walk along the boardwalk to minimize the time needed to reach his umbrella. So we're gonna use this formula and we're gonna graph it, and we're gonna find the minimum point. So as I also grab it right here. So we can see that this point is the minimum point, and after I find it, I got this result. And here's I say, so Clyde should walk 33.46 meters along the boardwalk to minimize the time needed to reach his umbrella. So here's this our formula, and this is how we graph it. So if any mistake, it's okay. You can tell me. And so that's it. Hope this helped and you can find it out. Thanks for watching.